A line L2 has this equation. Lines L1 and L2 intersect at a point C. B, show that the coordinates of C are -1, 1, 2. So I've written here line L1 from the previous exercise, and I know that line L1 looks like perhaps this, and I know it passes through my point 0, -3, 1, and it moves in this direction here, which is dictated by this direction vector, right? And depending on the value of lambda, it'll land wherever I want on my line. So I know that for some lambda, I'm going to end up right here. My line L2 is this one, and it passes through a point -1, 7, -4, -1, 7, -4, and depending on the value of s, it'll end up anywhere on this line, such that for some value of s, it's going to end up at my point C. So if I write my line L1, or any point that belongs to my line L1, as 0 minus 2 lambda, so just -2 lambda, -3 plus 8 lambda, -3 plus 8 lambda, and 1 plus 2 lambda, I know that for some value of lambda, it's going to end up at the same place as a point on my line L2, which is dictated by -1 plus 0 times s, which is just -1, 7 plus s, -4 minus s. Oh, and this is how I find any coordinate of my line L2. Now, what I can see from this is that in this case here, if I just equate the coordinates, the corresponding coordinates, I can see that for coordinate x, I have that -2 lambda must be equal to -1. So in this case, I don't have something in terms of s, which makes it easier for me, right? So solving this, I find that lambda is equal to half. And here I don't have to worry about the lines being skew or anything like that, because he's saying that they intersect at point C. So all I have to do now is substitute lambda for half where I have lambda, which is line L1, and I'll find my point of intersection C. So I can say C is going to be found by substituting lambda for half in all coordinates. So it'll be 3 plus 8 times half, 1 plus 2 times half. And that's going to be -2 times half is just -1. -3 plus 4 is 1. And 1 plus 1 is 2. That's my point C right here.